Hi, welcome to the lesson where we'll see how to stream changes from a data at rest storage thanks to a technology called change data capture. So to do that, I will, in my Docker Compose, you can see that I have my Kafka configuration as usual. I have a PostgreSQL database, and which is already configured for the Debezium purpose, which means the Debezium, which is a change data capture tool we are using in this module, which is quite popular also in the industry. And finally, I have also Kafka Connect that will try to link this static word of PostgreSQL to the dynamic word of Apache Kafka streaming. And in my example, I will use a visits table where I will add some data, typically during the execution. And in this file, you can see different scenarios that we will test in this demo, namely adding new rows, updating the existing rows, and deleting the rows physically, meaning that we should be thanks to the CDC, we should be able to see all these operations in our Kafka stream. So I will start the Docker Compose again, and I will register a Debezium connector, and it's maybe a good moment to explain the file, which is quite straightforward. It's a name with quite a basic configuration, specifically with the connection information and the filtering prefix for all the tables we want to synchronize to Kafka from PostgreSQL. And to visualize the data we are synchronizing, I will not use a Kafka client. Instead, I will use an Apache Spark structured streaming application that will do quite basic thing. It will just count the number of new devices per device type and device OS. And how can I know that the code will include only the creation, so only the insert? In fact, the Debezium adds some operation keys, and typically for all new rows, the key is equal to C, which stands for create, row creation, something like that. So let me now start the job. And meantime, I will access the console and add new rows. So the job has started, there is nothing yet created. And now I will add new rows that we should see later, just I think in a few seconds on our Apache Spark structured streaming code. Okay, that's correct. To complete this demo, I will start the consumer, even though I was saying that I will not do, and with the goal to show you what is sent from PostgreSQL to Kafka. You can see that there is some schema information, that there is also the payload with the information before, the row before and after, the operation key as I have mentioned before, and the transaction part. Okay, now I will try the second operation, and this second operation is an update that will not be taken into account by my structured streaming because of this operation flag on the C value. So my update will be a sample operations like that, and you can see that here I have my before row and after row that are different. You can see that the device type changed from smartphone to PC. I should have also probably changed the device OS, but that's not the point of being relevant in terms of data. Here is more to show you different concepts of the Debezium. So here you can have a quite nice way to compare data before and after, and maybe eventually trigger some alerts or detect some anomalies. And I have been saying before, there is nothing that happened on Apache Spark structured streaming because we have this visit payload op filter. And I will maybe stop the job because it does nothing for the rest part of the demo. Because in the next and the final part, I will delete some data. So I will do a delete from where visit is equal to true. And here too you can see that we have the visit free deleted, but this time you can see we have delete operation here and a following kind of tombstone message that is sent by the Debezium to the Apache Kafka topic. And this tombstone helps remove all the data. So previously, if we have been recording the changes for a row with a key A, and user deletes this key from the database, we will send this tombstone message as a kind of marker saying that, hey Kafka, when you compact all data which is all data for the key A, well, you keep only the most recent value, which is here the empty value, which helps to save some space and also better represent the last state for each key from the database. And as you can see here, there is thanks to the Debezium, there is a way, and as you can see here, thanks to the Debezium and more exactly to the change data capture pattern, there is a way to connect this static world of databases. Typically, I showed you here a relational database, but you must know that there are also NoSQL stores that support this CDC pattern. So to connect this rather static word to the world of dynamic consumption of the world of real-time and streaming processing. Thanks for watching and see you in the next lesson.